Welcome to our class. Today we continue with our lesson on how to deploy and verify contracts on chain. We introduced the same concept in our last lesson where we did deploy and verify Verifier.sol to Sepolia. We also did it before Sepolia. We had done it on our local machine using Anvil. So today we just want to go deeper. How do we deploy Verifier.sol, and then how do we verify? In our next lesson, we'll be looking at after you've deployed and verified, can you now interact with this contract on chain? So that is what we'll be looking at in our next lesson. But today, this is our concept. This is what we'll be looking at. So our goals, one, we'll be looking at how do we compile Noir circuit and produce solidity verifier. So we'll begin from there. And then two, we learn then how do we deploy this verifier, solidity verifier, a contract to Sepolia using Foundry. You remember in our last lesson, we looked at how to ensure that our accounts on Metafax are secure, so that we are using Sepolia, and using Sepolia, we are not charged any money. So we saw how to load Sepolia with the 0.1 ETH Sepolia, which is free. So we saw all that, how to load that. And so if anybody doesn't remember, we can still go through those steps. We went through those steps in our last lesson. So we'll be looking at, after deploying, how do we verify these these contracts on chain, and then interact with of course, interacting with the verified contract. I've said that this will be in our next lesson. But in this lesson, we'll be looking at troubleshooting and best practices during deployment and verification of these contracts. So what are prerequisites? These are the things we looked at in our last lesson. We have to ensure that we have them before proceeding with this lesson one. We require to have the Noir toolchain, which includes Noir, Nago, and so on. Also required to have Foundry, and this would include Forge, Cast, and so on. This should be installed and then initialized. We saw the use of Alchemy. There's that key we'll be using from Alchemy, and we saw in our last lesson how this is important, how that key will be used. And of course, we'll be using that key today, the one we get from the Alchemy, the RPC key. And then we also looked at Etherscan API, a key, and this one we said we'll be using it for verification of the contract. Once you've deployed it, you want to verify it. So for you to verify it, then you require this. Okay, the Etherscan is also used for deployment. We require the private key. A private key, this one will be getting it from Metafax. And I showed you how this is gotten. And as you do that, as you get this private key, you have to ensure that it is for a disposable account, one that does not have your real Ether. That is, should be that account whose private key you are using should not have your real Ether, your real ETH, because you see, if this key leaks to the public, then it means that you may lose your ETH through fraudulent means and so on. And so what you did is to safeguard the key that has your real ETH. And that is why we went and I chose, last time I showed you how to open another account that it does not have real ETH, and we used the Sepolia network. And then from there, we went and loaded our Sepolia network with the free ETH, which is obtained online. So that is what we did last time. And of course, if you did not attend that class, you can still watch the video, and so that you are up to date with what we are doing. Now, so the other thing that is required for this lesson is basic familiarity with the terminal, basic familiarity with the MetaMask, and the JIT. So those are the prerequisites for this lesson. Of course, all of them were covered in our previous lessons. This is lesson 129. So I'm referring to what we covered in lesson 127, lesson 128, and even lesson 126. What we covered there are very important for this lesson. Now, we have already done compiling Noir circuit, writing Noir circuit. We've done that. We even did it with Foundry in our previous lessons, but we just recap most of some of the things we did so that we acquire the solidity verifier that we need. So just a recap of what we are supposed to do. So once you've written your project, you would then do compile, Noir compile. And if you run Noir compile, what this does is that it builds the circuit and creates the verifier artifacts. And these are what we require. So we'll be doing Nago compile, no, not Nago build, actually. It's supposed to be Nago compile. You'd have Nago execute. Then you would use BB to do the proof generation and the verification and so on. Now, so in fact, in our previous lessons, we also learned how to automate these processes. Writing scripts to automate these processes, we did that, so we are also aware of that, and we can also do that. So that is after you've written your program and you've done Nago compile, you've done proof generation. Of course, we know how to do proof generation, even using yarn generate proof and many other ways we've used before. So once you've done all those, your target would have the following 5 files. So your target would be having the Hong verifier contract, which is the Verifier.sol. This is the solidity contract that will be deploying on chain and then proceeding to do verification. So this Verifier.sol would be in your target. Of course, after that, we'll be moving it from target to contract. That is where we'll be moving it because we will require everything .sol, all our contracts to be inside our contract. So we would have a folder called contract, and we know how to do that. We know what is supposed to be there because we've covered that in our previous lessons. So we'll then be moving this to contracts. The other thing we be having inside our target will be the proof.json. And now, so XX here stands for the name of your project. Of course, the name of your project will be inside your Nago terminal So if your project is, for instance, called first lesson, then this will be Noir underscore first underscore lesson proof.json. And the other thing we'd be having there is again the proof.gz. And I've said this will be compressed proof. It's a compressed proof. Even this proof.json is a proof in .json format. And then we'll be having public inputs, and we'll also be having the verification key, the VK. Public inputs, you know what they are? Of course, we are writing zero knowledge proofs. And when you write zero knowledge proofs, we have what is public, what both the verifier and the prover would get to know. And then we have the private input. That is what only the prover knows. The verifier would not get to know it. But the verifier needs to be convinced that the prover knows what this private input is. So what I'm referring to in the target is the public inputs, not the private inputs. Now, so we'll go straight to creating a project, but before that, I'm just showing you what is supposed to happen, what we're supposed to be having, and so on. So we'll then be required to prepare a Foundry project. If not already a Foundry project, we'll make it Foundry. So I had said earlier on that we'll have a folder called contracts. And I had mentioned that this is where we'll be moving our Verifier.sol, which was generated earlier inside our contract, inside our target. So this contract is where we are now making our Foundry project. So to make it a Foundry project, you get inside those contracts and then say forge init, forge, then init. So what this does is that it creates a Foundry.toml, also creates an SRC, creates tests, stroke scaffolding. Now, all these folders or files are very important to us, especially this Foundry.toml is very important. This tests is very important because we'll be putting our tests here and so on. So just say forge init, and then it creates all these files. So you'll just add there what is not there, but some would come automatically by just running forge init. Some would come automatically. Those that do not come automatically, we would then create them, we'll write those files. Now you can see the command for copying our Verifier.sol. We are copying it from target and moving it to contracts. Copy it from target because that is where it was formed. Copying it from target and moving it to contracts. Of course, you can always automate this process so that you don't need to be doing it manually every time. You can automate it so that every time it's generated, it goes straight to contract, that you don't need to be copying it again later. You automate this process. Now, after that, we will check to see whether our Verifier.sol, our Foundry.toml, the scripts and the tests, etc., are present in our contract folder. So that is what we will then be doing. So straight away, let me share with you project that I already created, and of course, is the same project we used. I'll not be getting a project from the scratch because we already did. We already created projects before, and we know how to create projects. So I'll just to give me some time, I open my WSL and get one project, and then we proceed with it for purposes of today's lesson. So you can also open your project, or if you can get the one we used in our previous lesson, you can have that and use it. So it's just the same steps we're using. Just a minute, I'm just okay, here is my project, the one we created last time. Now, as usual, we have this folder called circuits. And this circuits has our SRC, which has the main .nr. This is where we write our circuit. So our today's circuit is just about proving that you know that the private set that you have, when it intersects with some public set, you know the result. That is what we want to prove. So you're looking at the intersection of two sets. One is private, another one is public, and you claim that you know the result of that intersection. So that was what you want to. So this is zero knowledge proof. You don't want the verifier to know what your private set is, but you have some public set. The public set is known to both you and the verifier, but you want to claim that when that public set intersects your private set, then the result is known to you. Now, that is not the point today. The point today is after we have this set, can we generate a Verifier.sol and then deploy that verifier on chain on Sepolia and then verify. Now, so you can see where my nago.toml is inside our circuits. That means I have to get inside circuits. I get inside circuits, and then once I get inside circuits, I can do nago compile. I can do nago execute. And of course, you can see my circuit has tests, has unit tests below it. So I can also do nago tests, but those are not for today because we've been doing those ones before. Today, our point is just to ensure that we can compile, we can execute, and so on. So While I'm inside the circuits, I can do Nago compile. Okay, I've not written it properly. The spelling error, so Nago compile. So when you do Nago compile, you expect it to give us Noir C proof.json. Okay, I already have these. Most of these things I already have it. I already have them. I even have the build.sh, and we discussed about it in our previous lessons. This is a script to automate compiling. You can see I've written it to compile my circuit. And that is not the only work it does. The build.sh also does generate verification key, and you can see this is the command for that, generating verification key, VP, write VK, Oracle hash, and so on. Then after that, store that verification key inside our target. That's what I've written here. That's what it does. And the other thing that it will be doing is generating the solidity verifier, which we all need this time for deployment and then verification. So the solidity verifier is written by BB write solidity verifier. And this is the command that I've said that once it's written, store it inside a contract and store it as Verifier.sol. Without this command, it will then go straight to our target. It will go to our target. So you can see this is where it's supposed to be, inside our target. And we are using verification key, which is inside our target. Verification key is inside our target. So when we use this verification key, this will automatically go to the target. But we've said instead of going there, let it go straight to contract. That is where we've automated it to go. And I said we can always automate it so that we don't need to copy it from the target. But we create it and we have it go straight to our contracts. Now, so that is our build.sh. So let me just show you how, again, after enabling making scripts executable, after you make scripts executable, you can always run build.sh. And when you run build.sh, it's telling you that compiling, generating verification key, and then the scheme is ultra hung, finalized circuit size, and so on. The verification key is saved to target, and then now it's generating solidity verifier contract. Then the scheme is ultra hung. Then the solidity verifier has been saved to the contract as Verifier.sol. So that is what it's telling us. So when you come to contract, you would be able to see that Verifier.sol here. So when you click on it, this is what is inside. And this is our contract. In fact, when you scroll it to the bottom, you will then get to know the name of this contract. When you scroll to the bottom, you're able to see this, that the contract hung verifier is base hung verifier. So if you at the bottom, you can see the name of this contract. Good. So that is about how to create solidity verifier. Now, the other thing we will need to add, okay, we had said we create a Foundry project. And so when you do Forge init, as we had already said, it is going to give us this test. It's going to give us foundry.toml. Where is that? It's here. Although it will not be as it is here, I just added a few commands inside it to ensure that one, it has the optimizer to ensure that our contract is of the exact size that can be deployed, of the right size that can be deployed. And also, I'm referring, I want to use Sepolia. There's this RPC URL that will be very important. We are getting it from Alchemy. And this one it's already inside it's inside here, NV something. It's inside here. Good. And then we have this Sepolia key, the Etherscan API key, and then the chain. This is for Sepolia. This is the chain ID for Sepolia. And this is this one, you get this Etherscan key. And of course, I've already defined it inside my .env. It's already here, so I'm just referring to it from this point. I'm just referring to it. Now, so what did I add? I came here, this, and then I added this starter.t.sol. This will be defining how many public keys I have, and then what are these public keys. You can see my public key is 2. And I have only one public key. So this is how the starter.t.sol would look like. It's not different from Verifier.sol. They're not very far from each other. And this is the Verifier.t.sol. This is how you write it. We will be using it to verify. This is a script you use it to verify. You want to verify, once you've deployed your contract, you want to verify it on chain. So you can do it manually, actually, but we want to automate the process, that we use our scripts to do that. Now, to deploy it, you also require scripts, and that script is here. It's called deploy.s.sol. Deploy.s.sol is here. This is a very short script, and is the one we'll be using to do that, deploying. Of course, we will then have commands that will be assisting us to deploy. Okay, that is not the only thing we require. We also require the Cyprian verifier.app.sol. Here it is. Now, we've seen this before. We've seen this scripts before, but the most important thing here is giving us the length. This length is the number of public outputs, no, public inputs. That is so. This is how it looks like. We've written it before, so the first time you're doing this. Okay. Now, so the ENV has the private key, and I can just show you mine because mine has no I can hide it a bit. I don't know whether I'm hiding or there's no problem because mine has no ether. I decided we would use a key that has of account that has no ETH. Now, so the private key is we're getting it from MetaMask, and then we have the RPC URL, getting it from Alchemy, and then we have the Etherscan API, And then we have the chain, and this is for Sepolia. And then this part here, we are adding it to just ensure that our .env is not committed to GitHub, because I'll be committing this to GitHub. Just to ensure that it's not committed to GitHub, so that it's sent to gitignore. We add this. Okay. Now, I don't want to generate a proof because you already know how to do that. If you want, you can do it. But to generate a proof, you have to go get outside circuits, then get inside JS. Just show you. There are various ways of generating a proof. We've seen it before. So I'll get inside JS. Once I'm inside JS, I can say yarn generate proof, yarn generate proof. And we give it some time to run. And the proof has been generated. It's written here, proof generated, and the proof that is generated, you can always find it here. We have a proof here, and even these ones are proofs, but you cannot see them. They are, you cannot, if you click on them, you cannot read them unless you cut. Now we also have public inputs, and this public input is 2. These are hexadecimal number. Now that is how you generate a proof. There are other ways. Now, so our main aim is to deploy our contract, and then after deploying, verify. So to deploy it, we'll get inside our contract. Go inside our contract, that is where our contract is, the one we want to deploy. So just before I do deploy, I need again, for the sake of completeness of our notes, let's go to our PDF that we learn what we're supposed to do, and then we will come back and deploy, and then follow on it and verify. Now, so to deploy, you require the deploy script, deploy.s.sol script, which we all saw. I showed you where it is, how to write it. Of course, it's here. So to deploy, this is a command we'll then be using. So I just want to go straight. Let me just a minute. Okay, so this is the command we'll be using to deploy. So since you're also doing it from your end, look at my command. The rest will be the same. We only need to change this part. You go to your Acme as we did last time and get your command, your key. And then this will be coming from your Sepolia. So those are the only 2 things they'll be different. The rest will be the same for all of us. So I'm just waiting that you also open yours, acquire your tools. By tools, I mean acquire your keys, acquire your alchemy key, then also acquire your private key so that we then deploy together. Just replace those with and remember those keys must also be in your .nav, env, as I had already shown you. So you acquire them, include them in your .env, and then you write this command, and then we deploy. Okay, so I just want to share my project so that now as we prepare to now deploy it. You've seen the command, so I just understood. I'm also creating mine so that we can deploy together. Just a minute. Just a minute, I have to. Just trying to write my command, getting my keys. Then after So I have them from my, I have them on my e.env. So I'm just get them and paste them here. First one is my private key. Paste it there. There's my private key. Then the other one is my URL, RPC URL. RPC URL. Paste it there. Yeah, I'm ready to go. Okay, let me again share. Okay, so inside my terminal on the contract, I paste my command. You can see it has my private key, URL, and so on. Press enter. Successful with the warnings, function state, mutability, and so on. Good. Now there's something here, so let's just go through what it says. Script ran successfully, then it logs verifier deployed at this. So this is where, when you want to see it, this is where you go. I'll show you how to reach there. The chain is there. This is always the case for Sepolia. Estimated gas used is that. Estimated amount of ETH used is this, but remember ours we are using free ETH. And then Sepolia success hash is this. This is the address. This is the address. It's the same address we saw here. The same address. Now it says something that on-chain execution complete and successful. The transaction has been saved to home, Cyprian, Rust programs, and that private. So you come to contract. Under contract you have broadcasts. Under broadcast you have deploy.sol. Then we have this. So just follow that. Let's just follow that. Come to contract. This is where our contract is. Inside contract we have broadcast. Inside broadcast you have deploy.s.sol. Yes, in fact, we are already there. Deploy.s.sol. Then this ID, that is where we are told that transaction has been saved. So I think now they mean by transaction. These are what they mean by transactions. We have this. We have this. all these, and I think they're different. Now, they also say sensitive values saved at contract deployed sol that. So the sensitive values and their core, we have run latest.json. They're all these. So these are the sensitive information. Now, that is not important to me as such. What is important to me is how to take you to where our contract is, that you see it before we verify it. The problem is you would find that mine is already verified because I had already run this when I was preparing for this class. So you would find that mine is already verified. But let me just show you again something. The address. This is the address. Where is it? The address was somewhere here. In fact, it was appearing twice. In fact, it is here, this one. So let me show you a link that we would then use to see what our contract is. And I want to type it, inside our Nago here at the terminal just below here. So this will be the contract. This will be the address. I copy that address and just paste it here. So we'll go online here to see what our contract is. So let me now copy this and now go with you to our browser. I want to take it to the browser now. Here we see our contract. So that is our browser. I want to paste that link inside our browser, and you can see it's the same link. Then press enter. Now, so when you do that, you would see that contract creator is here. Of course, this is my address, and it has been created 6 minutes ago. This contract has been created 6 minutes ago. When you come, you can see it. It's ticked. This one is already verified because once you verify a contract and regenerate it, if it's already verified, it remains verified. It remains verified because you already verified it. So I'd already verified this contract of mine, but I've just regenerated it. Now, I wanted to show you where you find it, and this is how you find it using the address that was the address that we got. Now, this address is very important because, again, we'll go with it to the Verifier.sol, the Verifier.proof.t.sol inside our tests, and we paste it there. This the address, this address, we would use it. So we are using it, first of all, just to get us where the contract is online, on chain. And we've reached there. And again, the other place we'll be putting it is inside our verifier proof. Our verify proof, we'll be putting it there and we'll be using it. So we've seen where our contract is. So what follows is I'll want to take you through how do you verify it. Then after verifying, I would now come and we'll come back here and see how to interact with it. How to interact. So I'll tell you what it means interacting with the contract. Now we've already deployed our contract. The contract is already on chain. And this is just an example of the output we got. We were told the verifier deployed at, and we were given the address. In our case, this was not the address we've gotten. Every time you deploy it, you'll be getting a different address. And if you are deploying the same contract, you'll be getting a different address, but just pointing the same contract. Estimated gas, estimated total gas used, contract address, and you discover deployed at is the same as contract address. Then transaction saved to. So we saw all those. We saw all those when we deployed it. Now, very important is you save the deployed contract address. This deployed contract address that we've just seen. You save it, and we said we are using it. One, it will take you to where your contract is on chain. And two, we will use it for verification. We will use it for verification when we want to write the verification key and not the verification, the verify proof .t.sol. So for you to verify, you require this script. And this is just to automate the process of verification. You require this script. Now, I've said that address is important because you require it here. So you can see this is our address, verifier. This was the name of the contract, payable, and then our address that we got from the deployment process. So you have to put it there. You have to put it there. Important note, I've said once you have this, you've deployed the contract. There's this line in the contract, in this script I've already shown you. This line has the address that you used to deploy. So I've said this is the deployed contract address of the home verifier on the target. So from the deployment logs, that is where you get this line. So you're not getting it from the MetaMask, you're getting it from the logs, the deployment logs. Now, just before verifying, you require to know what compiler is used, what compiler you're using, so that when you're writing your command for verifying, you have to specify the compiler that was used. Now, to get the compiler that was used, we do a few checks. One, you can run, you run the command, this command, to view the top level structure of the contract. You run this command, JQ's keys out Verifier.sol and so on. Now, so this command is just to assist you view the top level of the structure. You want to know what compiler was used. If it doesn't assist you, then you look for compiler information. If it doesn't assist you, then we shall use the next command. Now, we will then look for this word metadata in the output. After running the command, look for the word metadata. And now, extract and search for the compiler details. Use this command. This command will then say once you find that once after running this metadata, now I put metadata here. You can see it's the same command that was above, but I've just replaced these keys with metadata. The rest remain, apart from this other part that will be assisting us now to get the compiler details. Apart from that, the rest remain. Now, if this does not help you, then you can come back to this other command. And of course, definitely this will then assist you. Now, any of these commands is supposed to assist you. You check one. If it doesn't, you move to the other. If it doesn't, you move to the other. But definitely there'll be one that will be useful to you. Because what you want is what compiler was used. And then once you know what compiler was used, we would then use that compiler, write it, would use that compiler in our verify command. So I've said that this command would then locate any line that contains the word compiler so that you can identify the exact Solidity compiler version that was used during contract compilation. Now, let me again show you something that we're looking for. When I say that we are looking for compiler, I'm just assuming that you've not already come to on-chain, you've not already come on-chain too. So if you not come, because this compiler is already seen on-chain, you can, in fact, you can see it on-chain. Let me just check. But I wanted to show you another way of getting it without necessarily going on-chain. So this is where we had deployed our contract. When you click on this word contract here, click on it, you can see something called compiler version. This is exactly what we are looking for. This compiler version is what we will then be using in our verification. So you can even get it here. But I wanted to show you how to get it on our local machine. But I've already again showed you the other option that can assist you get the compiler version. So let's use the option I was telling you. So we will run those commands I had already mentioned, and we see how they behave. The first command was JQ keys and so on. Let me just copy it. Just copy it. Let me clear this terminal. We are just doing it inside our contracts. This is the command, the first command. So when I run it, I can see the word metadata in the output. Metadata. So once I see the word metadata, we then said that would, if we notice that, we would then change the word keys to metadata, then add something grep compiler. So I've seen the word metadata. So I change my command now for the exact search of the compiler. Just said, okay, so this is my new command. Because of the metadata, I now have the word metadata here. It remains the same command. It remains the same command with the only difference at this point. Okay, let me press enter. And it says we have the word compiler inside here. Inside our contract, there's a word compiler. But now, it's not giving us the version. What we're interested in is the version of this compiler. This one, we're not interested with that the word compile exists, but it has given us some hint that we will get it. It has given us some hint that we'll get the version. So now to get yes. Okay, so let us run our next command. Just clear this, and then run this command. This is our next command. So when I run it, this is what I get. When you scroll it down, let's just scroll. You're looking for the word compiler. It must be in some color that we can see. Good. And there are various here. There are so many here. You can see we have this. You can see we have this. I think they're the same. Let me just copy this one first of all. It ends here. We copy it and paste it here. There we can see. Okay, so the version is, this is the version. We also copy this. It ends here. Just want to see whether they are the same. They are the same. They are the same. I don't know if there is another one down here. It's not there, but we have seen the compiler, and it's the same compiler we saw on chain when we went to where our contract is deployed. is the same one that we saw. So we'll be using it to write our command for verification. We'll use it to write our command for verification. So now the next thing is for me to show you how the command for verification looks like, and then we go and verify our contract. Now verify the contract on Sepolia. This is the command. Now run the following command. Replace the compiler version if yours differs. So my compiler version that I got is this. So my command will be this with this compiler version. So just check yours and see if it's the same. Then you will also acquire the ETHScan API key. This is your address where you deployed to. It must be there. Those are the only things that we require here. Remember this address. It also, we had used it to get to know where our contract was deployed. So let me just straight away go to get my command in order so that we can verify. Remember, for me, I had already verified my contract, and therefore I expect to tell me that it's already verified. But for you, since you had not verified, you expect it to verify first. So again, I'll work from this Nago terminal. This is where I'll be creating my commands. So this is so let me get what my address was. This was my address. So I replaced the whole of this with what my address is. The other thing I need to change is my compiler version is the same. My compiler version is the same. But now the ETH API's key, I had already saved it inside my env. So I can just copy it here. I can just copy it, then paste it here. So it should read forge verify contracts. Then what follows is the address where it's deployed. What follows is a /verify.sol and that, and then chain Sepolia, then compiler version, then optimization 200, then the ETH API key. So this is what I copy and then paste in my terminal. And for me, I'd already verified. So since I'd already verified, it tells me that this contract is already verified. So it then skips verification. But for you, since you're not verified, it will begin by verifying. It will begin by verifying. So you can see for me it started start verifying contract, then it deployed on Sepolia, compiler version, and then optimization 200. But then it discovers that it has already been verified. Now, so after verifying, what do you do? After verifying, what do you do? Expected response. For you, what you would have gotten would have been this. What you would have gotten will have been submitted contract for verification, okay. GUID, then there will be some number here. Then URL, this is the URL from Alchemy. So this is what you would expect to see as the response after verification. Now, so you would want now to check the status of verification. And for you to check the status of verification, you require this number, which is already in your response. And you have this command that you then use. So this number here is what you write here. This number is what you write here, the GUID number is what you write here. This remains the same thing we've had before. And so the rest are not keys, it's just telling us forge, verify, check, chain, Sepolia, ETH scan, and so on. And then this number here. Now that mine was done long ago, I don't know whether I remember what it was. I can say I deleted this one. Okay, so I don't remember what mine was because I don't know whether it will accept to run without that. Without this number, it will not run. But we can just try it and see. Okay, so I'm just want to see whether I can get my GUID number. I think I can get it inside broadcast where we were told that is where important things are stored. So when I come to this broadcast, I'm supposed to get my GUID number. Let me just see whether it's here. Just checking. Because without it, you cannot then verify. You cannot verify. The guide number, the guide. Okay, I cannot see it. So let's try to. Or we can try to find it. Maybe it CD broadcast. That we can search for it. Let me see D11555111. No, that one is not possible. So let me just search for it from broadcast. Again, is not possible. There's no problem. It's no problem. So let's come back here and try with this. Just try with this without the guide number and see what we get. Seems this one will not run. Supposed to run it inside contracts, inside broadcasts. So let me run it inside contracts. It will not run. Says the following argument is required. So it's asking for the guide. It's asking for this key. I think we can skip that step because that step was just to show that the contract is verified. But for us, it's already verified because when he ran that command, it told us that it's already verified, and therefore it was to skip the verification process. So for us, we don't need to verify that it has been verified because the command already told us that. The command already told us that it's verified. So I think let's stop at that. And then next time we look what how do we then interact with it after it has been deployed and verified. Thank you.